Radical equations. Solve radical equations containing one radical. A radical has a small number called the index, right about there. And if there's no index written, it's automatically a 2, and that would be a principal square root. Generally, the radical has index of n, and n will be a counting number starting with 2 or 3 or 4 or 5. Number 1, solve the principal square root, index of 2, understood, of 4x plus 1, subtract 2 equals 3. And let's note that it's understood the square root in this problem has a coefficient of 1. It will not always be a 1, but it is in this example. First step, step 1, is to isolate the radical by adding 2 to both sides. So 3 add 2 will be 5. So we have principal square root of 4x plus 1 equals 5. Step 2, raise both sides to the power of the index, which is 2. The index is 2, so we square both sides. This is also called the power rule, which means if we raise both sides of an equation to the same exponent, same power, we have an equivalent equation. So that looks like this. Parenthesis, principal square root of the radicand quantity squared equals 5 squared. Squaring the square root will eliminate the radical or the square root, so we get 4x plus 1 is equal to 25. And now we use algebra. So 25 subtract 1 is 24. So 4x equals 24. When we divide by 4 on both sides, we get x equals 6. If we were checking, we would substitute 4x 6. So we have 4 times 6, add 1, minus 2. Subtract 2, does that equal 3? That's the principal square root of 25. Minus 2, does that equal 3? So that would be 5 minus 2 does equal 3. 3 equals 3 is a true statement. So the verified solution is 6. Number 2, an extraneous solution would be a solution you find at the end of the process of solving, but it would not check the original statement. So an extraneous solution does not check, or let's say solve, the original statement, the original equation. Number 3, when solving radical equations, what is the key first step is to isolate the radical with a coefficient of 1. With a coefficient of positive 1. For example, number 4, we have the principal square root with a coefficient of 1. Add 5 equals 2. All right, so let's begin by isolating the square root term, subtracting 5 from both sides. So we'll have square root of 7x plus 2. And 2 subtract 5 is negative 3. Since the index is understood to be a 2, we'll use the power rule and square both sides. In other words, square negative 3 in parentheses and square the square root of 7x plus 2. Squaring will mathematically eliminate the square root, so we get 7x plus 2 is equal to 9. Subtract 2 from both sides, and we get 9 minus 2 is 7 equals 7 times x. Divided by 7 on both sides, so potentially x equals 1. So part A, what value did we find for x? We got x equals 1. Does it satisfy the original equation? So let's plug in 1 to verify. Check the solution. We have 7 times 1 plus 2. Add 5. Does that equal 2? Well, that's the square root of principal square root of 9. Add 5. Does that equal 2? 3 plus 5 does not equal 2. This is false. The answer is no. Part B. The solution set is the empty set. There is no solution. So we've just used a pair of curly braces, the empty set, to mean no solution, since the solution, 1, is an extraneous solution. Or we can use the null set symbol to indicate no solution. Without solving, how can you tell in advance the equation has no real number solution? Well, it's because right here in this first step, let's draw this arrow here. Whenever you have a principal square root of a non-negative real number, so a number that's positive or 0, will always be positive or 0 and will never be a negative number result. So that's how you can tell right away whenever you have a square root coefficient of positive 1 equaling a negative number. In the set of real numbers, there will be no real number solution. So right there, you could stop and say no real number solution. Number 5, solve the radical equation, which has a coefficient of positive 1 and the index is 2. That's a square root. All right, so in this kind of a problem, the first thing we have to do is isolate the radical. And to isolate the radical, we need to subtract 1 from both sides. So we have the principal square root of x plus 5 is equal to x, and then subtract 1 from both sides. Since the index is understood to be a 2, this is a square root, we're going to raise both sides to a power that equals the index and square both sides. So square the square root of x plus 5 and also square the right side, square x minus 1. So on the left side, squaring the square root will eliminate the square root. So we get x plus 5 is equal to, on the right side, the exponent does not distribute. You have to multiply this out, FOIL it out. So we get x plus 5 equals x squared. Now the outer product and the inner product combined is minus 2x and then plus 1. So we have a quadratic equation with a leading coefficient that is positive. So we want to keep a positive leading coefficient by subtracting x from both sides to get 0 on the left-hand side, and we'll subtract 5 from both sides. So we have 0 equals the quadratic equation, which looks perhaps factorable because the constant minus 4, we can use the factors 1 and 4 with the correct signs. To get a minus 3x as the middle term, we'll multiply x minus 4 times x plus 1. Check by foiling that you get minus 3x and minus 4 as the constant. So we find that either x equals -1 or x is equal to 4. Part B, does this value or values satisfy the original equation? So let's check. Let's check -1 first. So we have the square root of -1 plus 5, then add 1. Is that equal to x, which is -1? So that's the principal square root of 4 plus 1. Does that equal -1? The principal square root of 4 is 2. 2 plus 1 does not equal -1. 3 equals -1 is false. So that solution doesn't check. So let's check 4. Plugging in 4. Let's do that here. We have the principal square root of 4 plus 5, then plus 1. Is that equal to 4? Principal square root of 9, add 1. Does that equal 4? 3 plus 1 is a true statement. 4 equals 4. So 4 is the solution inside of the curly braces, and we state that -1 is an extraneous solution, a solution that doesn't check, an extraneous solution. Number 6, solve this equation where the algebraic expression has a coefficient of +1 and it's raised to the 3/2 power, or a rational number exponent, -2 equals 6. The first step is to isolate the algebraic expression containing x by adding 2 to both sides. So 6 plus 2 will be 8. So the first step will be to have 3x plus 1 quantity raised to the 3/2 power equals 8. Now the power is 3/2, which has a reciprocal of 2/3. So an example like this, problem like this, we're going to raise both sides to the power 2/3, which is the reciprocal of 3/2. So noting that the reciprocal, or multiplicative inverse, of 3/2 is 2/3, because when you multiply reciprocals, the product would be 1, right? 6, 6, which is equal to 1. So what we're going to do, let's insert some brackets here. 3x plus 1 quantity raised to the 3/2 bracket, we're going to raise that to the 2/3, because when you raise a power to a power, you multiply these fraction powers and their product is going to be a 1, thus canceling the fraction exponent. And do the same to the other side, raised to the 2/3 power. So that gives 3x plus 1 quantity raised to the first power, again, that's because you're going to get 6, 6, but 6, 6 is equal to 1. So you can just leave that out and altogether. Just it's understood it's going to be an exponent of 1. Now, 8, we want to prime factor 8 as 2 to the third power, because when you write 8 as 2 to the third and then you raise that to the 2/3, you can multiply those exponents and simplify. So we get 3x plus 1 is equal to base 2, and then with mental math, or you can write it down, 3 times 2/3 is a product such that the 3's will divide and cancel out. So you get 2 squared, which is 4. So we have 3x plus 1 is equal to 4. So subtracting 1 from both sides, we have 3x equals 3. We propose that x equals 1. Well, let's check this. Let's substitute 1 for x in the original statement. We have parenthesis 3 times 1 plus 1, quantity raised to the 3/2 power, then minus 2, does that equal 6? So that's 4, quantity raised to the 3/2, then minus 2, does that equal 6? We can change the 4 into 2 squared. We want to do that because when you raise 2 squared to the 3/2 power, you can then multiply those exponents. And when you multiply those exponents, you get 2 over 1 times 3 over 2, and the 2's divide and give you 1. So 2 to the third power, which is going to be an 8, subtract 2, does that equal 6? So 8 minus 2 is 6, and we get a true statement. So the verified solution is 1 inside of the curly braces.